Hello and welcome back to the Global AI Student Conference. Did you love the videos on the Microsoft Learn Student Ambassador Program and Seeing AI? I think the part that I found super cool is that students are demoing the tools and technology at this conference, image detection, object detection, speech to text, that is being used in tools like Seeing AI. So I'm super excited to see what they do in the future. But now I'll pass it off to Futini to introduce our next speaker.
Thank you, Loxley. I also love the videos that we see about our student community and the Seeing AI. So our next speaker is Sifa Kinoti, an environmental engineering student in the University of Nairobi. And she is going to talk about AI in tracking air quality. Hi! Welcome to the show.
Can you hear me?
Yeah.
Yes. Thank you so much for the opportunity. I am going to go ahead and share my presentation, if you don't mind.
Yes.
I'm going to go ahead and share my screen. I hope you can see my slides.
Yes, we can see your slides.
Okay. So my laptop is a bit slow. Kindly bear with me. So this is what the presentation is about. It's going to be about air quality visualization. And this is me. My name is Sifa Kinoti. I'm a data science and AI enthusiast. I took a short course in data science from a school called Jenga School, and I'm yet to graduate. And I took it as a minor, but a major, I'm doing environmental engineering at the University of Nairobi. I'm currently in my 4th year of study. So, of course, University of Nairobi is in Kenya's capital, Nairobi. So this project was motivated by the challenge that has been described as one of the biggest challenges of this century, needless to say, climate change. Of course, we're all facing dire effects from climate change, especially here in Kenya. So I wanted to see, or rather I wanted to investigate, how can AI help in this fight against climate change? And we know that climate change comes from air pollution. This is where we release toxic gases into the atmosphere, and they're called greenhouse gases, and it has this whole greenhouse effect that raises the temperatures. So what can we do? The goal of the rationale of the project was to measure these pollutants that are present in the air, such as we have many different pollutants. We have particulate matter, and it's also divided into different branches. We have particulate matter 10, we have 2.5, and we have 1, and it's all divided according to how thick the radius of the particulate matter is, of how the molecule is. We also have ozone, we have methane, we have the very popular carbon dioxide, carbon monoxide. So what we can do, we can measure it in the air. We know the trends. This is where it's coming from. This is its concentration. And then we can also create algorithms to visualize so that we can see maybe in the western part of Nairobi, it's on a downward trend, and the eastern part, is it on an upper trend, to answer those kind of questions. And then it would also be interesting to investigate, or rather to see if we can predict the value of the pollutants. And this we do using neural networks. I investigated using LSTM. LSTM is short for long short-term memory, which I will get into later. And what do we do with this information afterwards? This information can be used to advise policy. This information can be good for you as a citizen, as an active citizen, to know what's happening in your world currently, and to also know how you can take action, whether you should wear a mask, whether we can plant more trees, and so on and so forth. So this is the basic workflow of such a project. The first thing, you collect data. I was fortunate enough that for the data that I used in this project, it was made open source by a company called Sensors Data Africa. It's an NGO that works to put sensors all around cities in Africa in order to measure air pollution, water pollution, and sound pollution. And the data is open freely. I think they've been collecting it since 2017. It's open on that website, Open Sensors Africa. So of course, it's a time series model. A time series is it's a kind of data set where the values vary per time, or rather you collect these values every second or every minute or every hour. So you have the column for the value that's coming in, and you also have the column for the data. So in a time series model, of course, you will need to look at it, you'll need to clean it, and you'll need to transform it. And the package that I use the most over here is pandas. Of course, it helps you to see if you have any null values, and it helps you to do feature engineering. You can end up merging columns, you can end up creating another column from the columns that you actually have. And I will show you one that I created. And you'll also use another package that I forgot to mention here to check for something called stationarity. So stationarity is you conduct a stationarity test in order to look at the trend and the seasonality of this time series data set that you have. So basically you want to see if the average is moving, if it's going up, down, or if it's on a constant upward trend or a constant downward trend. You need to check for that because data science is all about statistics and learning from patterns. So if you want to put this data set into a machine learning model, it's important that you put it in a way that the machine learning is going to understand it, in a way that the model is going to be able to detect these patterns. So something else that we also do when we're transforming the data is differencing. We do the differencing so that we, sorry. Sorry, I think I had stopped for a while. You do the differencing so that you can bring all this data around the same average so that the machine learning algorithm can be able to detect the patterns. And I was saying the last thing, yes, that we need to do is scaling. Now you realize that sometimes you might collect information that has varied, very varied values. You can find that in the same data set, you have values that are ranging from 0 all the way to 1,000. Now this makes it difficult for the model to predict. So what you need to do, you need to scale it. You usually have either the min-max scaler or the standard scaler, where it does some maths behind the scenes so that you can bring your values down to either 0 or 1. And that way the machine learning is able to understand the trends in your data set. Then afterwards, we move into the LSTM modeling. As I mentioned, LSTM is a neural network. It's a recurrent neural network. And I use the one from TensorFlow. You use a package called Keras, and I will show you that later. Then afterwards, I evaluated using the mean squared error. In short, you can see that it's MEC. And I would suggest, as used in this project, I deployed my data on Dash, and I used Heroku. Or rather, I visualize the data on a dashboard, and then use Heroku to finally deploy it. So kindly give me a second as I switch to the GitHub. Yes. So this is a GitHub account. I will share the details and I will make it public right after this presentation. But I just wanted to do I wanted to show you how the project looks like with code. So basically I did just a little bit of write-up, an overview, what I've talked about how clean air is very important and how air pollution is a major cause of climate change. And later I went into something called a CRISP-DM methodology, which would be important for students to understand, or rather students to employ in the data science projects, in the AI projects, which is basically a framework for how to conduct your project. So what I did was a bit of business understanding to understand the objectives of this project, which is basically to track and identify various pollutants within the city. I looked at the availability of the resources, which, as I mentioned, I was fortunate enough to use the open source data from Census Africa. And you also analyze the risks and contingencies. Of course, something that we always say, we don't have enough data, especially here in Kenya in regards to air pollution. So I'm hoping that this is something that I can create awareness of. And another risk and contingency that I should have added here is that you need a lot of desktop power in order to run such a project, because you'll be using a lot of data. So the data mining goals, as I said, the goal is just to identify and track pollutants. And then you also have the project plan of the city, a project plan of the project and to help you plan. And then, of course, you collect the data and you import the necessary packages that we're going to use, as you can see. I was using Colab, so I imported them from my drive. And then you can look at how this data has been preloaded, so it's already been transformed, but this is just basically how it looked like. We had the sensor ID, the different, this is to identify each sensor where it's been put in various parts of the city, and the sensor type. So the different types of sensors, some that measure particulate matter, some that measure temperature, others that measure humidity, the location. Later on, you realize that this project has 17 locations within Nairobi. And of course, the geocoordinates, the timestamp. So this is what I was saying about it being a time series model. It means that information is being collected every second. As you can see here, it's actually every microsecond. And the value types and the value, and you have the day, if it's a Monday, if it's a Tuesday, if it's late at night, if it's early in the morning. And then it's also important for you to describe the data, to look at it, to check if there are any null values, to check if there are any duplicated values, to check the shape. I'm sorry, my laptop has a bit of, the laptop power is a bit low, so I wasn't able to run all of this beforehand, but you can definitely clone this and run it in your device after I've made it public. When you check the shape, it has so many values, and then something that's very important is that you need to convert it to datetime. When you convert your column that has the dates to daytime, it makes it much easier to work with. And then I renamed the value types because at first they weren't as they were. As I said, I transformed it beforehand. And then I also created, I plotted them on the map so that I see how distributed these sensors are. And then I replaced because at first the locations were they were encoded, as you can see with these numbers, and I replaced them. And I also added a day and time column because I thought that it would be interesting to see the variations per time, like how does the data look in the morning versus in the evening? How does it look on Saturdays versus Mondays? Yes, and then I did a bit of locking the data over here so that I can downscale it. This data set had very, very billions of values. So I wanted to downscale it so that I'm able to train the model. So this is some of the feature engineering things that I was telling you about. I added an AQI bucket. So this bucket is just to classify. It will look at the value and then it will tell you this value 42 Friday morning, it was unhealthy for sensitive group. But this one on a Friday morning, it was good. This one on a Tuesday night, it was moderate. I did that so that it's easier for us to understand where these values lie. Instead of just telling you 95, 29, 11, you wouldn't really understand what it is. So here now I moved into filtering the data further so that I can now do the modeling. So what I did, I picked the top location, which is rerouter, and then I dropped all those other columns because I just want to do the modeling. And then you lock the first 5,000 values. And then always remember, because when you lock, you're creating a new data frame. So remember to do the formatting that I showed you earlier about changing it to daytime. Otherwise, you wouldn't be able to you wouldn't be able to plot it and also manipulate it, and also to set it as an index and to set the frequency. And you also check for stationarity, which I told you checks whether your data is good enough to be modeled. And then, of course, you split into the testing data and into the training data. I used the 0.3, which is very common. So the test size was 30%. The training size was 70%. And then you define your time series generator. This is from a package from TensorFlow from Keras. And then you're also supposed to define your input and the features. So this features, one, means that we're only looking at one thing, which is the which is a value that we're going to predict. And the input is how many values that we want to how many values you want to use in the training data set at first. So use the first 1,000 values and then use the next 1,000 values and the next 1,000 values. Then there you're also supposed to define the batch size and yeah. Afterwards, you go to create the model. It's a sequential model, LSTM, added 50 units. You have the ReLU activation. It's very important to use some of these parameters because because they improve the accuracy of the model, such as the learning rate, the dropout, the activation, and dense layers. These are hyperparameters that you keep on playing with to see which one will give you the best machine learning model. And then here we just looked at a summary. So we're seeing that we have 10,808 trainable parameters. For purposes of this presentation, I ran it using very, very few epochs. Normally, something that you'd use a little bit more epochs because the more it trains, most of the time, the more the accuracy improves. And there's a special function that you can use called a callback, where you can do something called early stopping, where it analyzes these losses that you're seeing at the end here. So when the model notices that, okay, the loss isn't really increasing or decreasing at this point, we can stop the running, and then this is the best model that you can generate. After that, you plot your loss. You plot it to see how it's functioning. Normally, they usually run down like that, but it's a smoother curve. But as I said, for purposes of this presentation, I did not use the best parameters because of the laptop power and and so on and so forth. So afterwards, you want to predict because you've already modeled. So here we're looking at, as I mentioned earlier, you take like the first 1,000, you predict, the next 1,000, you predict. So you want to now predict them in batches. So that's what you want to do here. You want to create the batches and then you call the first, this 0 is supposed to call the first item in that array, and then it'll give you the prediction. But remember, you can also remember that we transformed this data earlier using the min max. So something that you're supposed to do, you're supposed to inverse transform, because when you do min max, your data is between zeros and ones, and that's not accurate. So when you inverse, it's back to 79, 25, 24. So you do the inverse scaling, and then you add them on a predictions, you visualize them, your test prediction, and then you evaluate it using the mean squared error. Normally, you'd want a mean squared error that's as low as you can get, as low as possible. Then you pickle load the model. So this is something that you do when you want to save the model, and so that you can use it in a different model. So now we've predicted for rerouter, but what if you want to find out how the quality is in the central business district? So that's why we pickle it so that we can save it, and then we load it in a different place so that we can use it. Now, that's most of it about how your Jupyter notebook will look like when you are doing an air pollution, or rather an air quality model. And then when you want to now visualize it and present it to people, so this is how your code would look like. So as I mentioned earlier, I prefer using Dash. Dash is a framework that's Dash is short for dashboard, and it's used for visualizing, or rather presenting your data science findings in a unique way. You're telling it as a story. People can come to your website and they can understand what's going on. So normally when we are using Dash, these are the most important packages in Dash: the DCC, which is a Dash component, the HTML. HTML is, I'm sure most of you know, it's just about how you write your markdown, how you present your wordings, and then you also have the input and the output. So the input and the output is important because it allows the user, or rather, this is what defines how the user will interactively use your website. And then, of course, Dash is built on top of Plotly. Plotly is another amazing library that I like to use because they do interactive mapping and pandas. So you import your data. I should not have shown my Mapbox token, but that's something that you're supposed to load and then you define your Dash app. And then normally you just create a layout. So what I wanted this layout to look like is that the user comes to the dashboard, and then they have certain things that they can manipulate. So the first one here is a location. We're going to ask you which location do you want to, we're going to ask you to specify the location where you want to visualize the air quality. We're going to ask you also to specify the value type. Excuse me. So as you noticed in the Jupyter notebook when we were doing the exploratory data analysis, there were different types of values. There was a humidity, there was temperature, and there was a different levels of particulate matter. So say they want to look at the temperature in the central business district, and then here there is a time. Maybe you want to look at how it looks in the early mornings or in the late evenings. The day you want to see how it looks maybe on the Saturdays, on the Fridays, and you also pick a date, or rather a date range. So this would help when you're mapping. So the Dash components that I used here is a drop down and checklist. So what this says, or rather the components that you're supposed to put inside the checklist or the drop down, you have the options. The most important that need to be there is the options, the value, and the ID. So the options is the options we loop through all the locations that are in the data set. And then for the value is just basically what is inside the options. So in the options, we had Central Business District, we had Muthaiga. So in the value, it's going to be the same. It's going to be the same list, but now the value indicates now what the user is going to see. And then we have a special ID for this checklist. It's called location. And the same thing happens all the way down to the rest of the drop downs and everything. And then you define a graph because you'd want to look at, say, the time series, how the values trend over time. So those are different graphs that you can do. And then this is also something that's very important for you to know when you're doing your Dash application, the callback. So the callback is what connects the outputs and the inputs. When you have multiple inputs, like in this case, you would put them in a list. And then your output would be the map. So for example, in this callback, you remember we did that checklist for which location do you want to see, which value type, which things do you want to see. So this is what is being input over here, the ID, and then the value, this value that we indicated over here, for example. So you link that output and that input, and then you define a function that's going to draw up the map. And inside the function, you put in different, sorry, this one isn't that correct. Inside here, you put now this chosen location, it matches up to this first input, which is the location. And this chosen value type, it matches up to this value type. So those are the parameters that it would use, the location, the specific location, and the specific value type. And then you can also draw up now your scatter map box. And then this is a sample code of how it would look like, and then you return the map box. And something that's important for you to do is to create a new data frame when you're defining these functions for graphing, so that it doesn't keep on, so it creates a copy of your actual data frame, so it doesn't keep on going back to the actual data frame. So after you're done with everything, you're supposed to call the application and it will now set up and run. So something that I have not experimented with before, but I was told about right before the beginning of this presentation, is about Heroku. So Heroku is something that can help you, or rather it's a platform that helps you deploy your Dash application. And I think it's something that we should all look into. So that is the end of my presentation. I'm going to stop sharing and I am open to any questions now.
For your presentation, I have to say that it's very inspiring to see students using all the AI technologies for projects for social good. Now we have a couple of questions for you. So the first one, is that
Yes.
traditional, a lot of data tracking systems on weather, air pollution and quality is not updated in real time. So you use data from the open source on Africa. How is this data updated? How,
Sorry, how is this data?
how often is data from open sensors Africa updated?
It's actually updated in real time, which is a very, very interesting thing. But I was not able to incorporate that into this project, but it's something that I'm looking forward to doing.
Yes, it's very great.
Okay.
So the next one, you are an environmental engineer. So how essential is technology analysis supporting climate change?
How is? Sorry?
How essential is technology analysis to support climate change?
How is the sensors technology supporting climate change?
Yeah.
Oh, yes. For example, in this project, you're using sensors to detect the air pollution. And air pollution is directly linked to climate change because it's what's directly causing it. So that's one of the ways that you can use sensors in order to fight in order to fight climate change. There are also other different ways you can look into, aside from air pollution, you can also look into how it's affecting the water, the soils, and other aspects of our lives.
Awesome. I think I have a couple questions. First of all, I just think it's amazing that the data set updates in real time. And I know one thing
Yeah.
that you said in your talk was like that you were super excited to explore that in the future. So I'm super interested to
Yeah.
hear what are like your next projects that you're looking forward to using this data or other data on.
My next project, I'm actually looking to continue building onto this project because I feel like it has so much that I can do than this. I'm still a beginner in data science. I'm looking to using more Microsoft platforms, like seeing how I can link it with Azure, seeing how I can build it into something that can now be deployed in the industry and not just on a dashboard.
I think that is so relatable. Even I remember one thing you said in your talk was how the like processing on your computer like might not be
Yeah,
as fast as something in the cloud. And that was something that we had a speaker
yeah,
earlier say that like right now, like the processing you can do on your own computer, like using the cloud, suddenly you have all of this access to computing power, which I want you to come back at next year's Global AI Student Conference and do a talk on
definitely,
that because that would be absolutely
definitely.
amazing. I think
Yeah.
maybe my final question for you, because we have a little more time, is what are you like, even what was your favorite things that you learned so far in your research and in like the data science space?
Oh, wow, there's so much. When visualizing this data, I didn't actually realize how dirty the air is.
Mm.
I did not realize that. And I think it's something that's why I want to continue building it to deploy it into the industry so that people can be more aware that the air that we're breathing in is really, really not good. And, it results in a lot of respiratory issues. The other thing that was very interesting for me to learn about was working on a time series model. There's a lot, I experimented with a lot of models such as Arima, the Facebook Prophet, also scikit-learn based scikit-learn-based ones like Random Forest and SVM, but learning how to create this neural network was a big challenge to me, and it was something that I really enjoyed.
I think that is super awesome. And I think actually we have time for one more question. And let's see, do I remember this final question I was going to ask you? I had it and then it escaped me. Let's see, it'll come back. No, I think actually no, the thing that I think is super cool about your data and the research you've done is it's both impactful at like a small scale with like direct things that people can do with it, but also on the big scale with hopefully causing like massive social change. So, what are like the
Yeah.
impacts that you foresee that this research and your project having on like your community and the world?
Yeah. Well, for one, of course, it'll create awareness on the current state of air quality in Nairobi. And this can put pressure on the government to change our policies and to change our laws and to do more. If it's planting more trees, if it's looking into more climate change technologies that can mitigate this, that's something that I'd really want to push for.
I think that is super excited, and I'm also super excited
Yeah.
for you to continue doing that research. So thank
Thank
you so
you. Thank you
much.
so much.
And thank you so much for coming on the conference today. I'll now pass it back to Fatini to introduce our next speaker.